Hello, Mrs. Boyd here, and today we're talking about measuring heat change using a calorimeter. We can also call this enthalpy in our case because we are going to be keeping our system at a constant pressure. So basically, you're going to be determining the enthalpy or the heat change of a reaction. Or in our case, we might also put a hot or cold object into our calorimeter and just measure the heat transfer from the object to the water. So to do this, we need two really important tools. The first is a calorimeter, and ours are styrofoam coffee cup style calorimeters, and they're going to have a lid right here and a thermometer, and we're going to measure how much the water's temperature changes from the beginning to the end, and that's what we call delta T right here. And I also have pictured a little object that's either going to be cold or hot. You might also be doing a reaction like as a hot pack or a cold pack, and we can also put that there in the water and measure the temperature change of the water. All right. Then the second tool that we have, really important, is Q equals mc delta T. So this is our equation that is going to measure our heat for us. So let's just jump in and see how we can use the equation tool first. And as we go through the equation, I will tell you exactly how to find each one of these numbers and what are the units for those numbers as well. Okay, so first we have everything written right up here that tells you what Q and delta T, M, and C, what they stand for. And then let's jump into M to begin. So M, as you see above, is a measure of mass of the substance. So because we are concerned about the temperature change of the water, we're kind of seeing this whole thing through what's happening through the eyes of the water. We want our M, our C, and our delta T all to be for the water. So how do we find the mass of water? Well, pretty simple. We can weigh it on a balance, or if we know how many milliliters we have of the water, then that can tell us also how many grams, because you might recall that 1 mil equals 1 gram. So you either know the milliliters or you weigh it on a balance, and as you're starting to figure out, the units are going to be in grams. All right, what about the C? C stands for the specific heat of a substance. Whoa, what the heck is that? Okay, specific heat is a number that basically tells us how hard is a substance to heat up. If it has a high specific heat value, then it takes a lot of energy to heat it up, something like water. If it has a low specific heat value, then it means that it's going to be pretty easy to heat up, so something like metal. So I kind of said a lot of words in there, so let's kind of write this down. Specific heat, let's go to units, is going to be a measure of how much energy, which we measure in joules, it takes to raise 1 gram of that substance 1 degree Celsius. So it's kind of an awkward unit. It's J divided by grams degrees Celsius. And honestly, we just looked this up on the internet. Okay, so internet or table, a chem book, anything like that. Some trusted source will give you the specific heat value of your substance or your chemical reaction. Okay, then we have this last variable here called triangle T, delta T, and that is just the temperature change. And so we find temperature change using a thermometer. And we are going to use the thermometer inside the calorimeter. We're going to stick it in the top hole of the lid of our styrofoam coffee cup style calorimeter. And the units for that are degrees Celsius. Okay, so we have our 3 numbers, and hopefully it's becoming obvious to you that when you have 3 numbers kind of squished together in an equation like that, you just multiply them together, and that's going to get your Q value. So you multiply your grams of your substance multiplied by your specific heat of your substance multiplied by the temperature change of your substance. In this case, of water in all 3 cases. And what that will get you is your Q value, energy, and that is measured in joules. Remember I said earlier that we are measuring our energy in joules. And just to give you a little bit of a reference, I have this little gummy bear here, my favorite candy, and we know that 1 gummy bear has 7 food calories, and that actually equals 29,288 joules. So just to kind of give you a reference point, So we are still talking about the same thing. We're still talking about energy, but we're just using a different way of expressing it. The units in this case in chemistry are joules. Oh, another thing, you knew that it was joules because you see how we have joules on the left and we have joules on the right? I bet you that's because everything else canceled out, and sure enough it does. We have grams on the top, grams on the bottom, degrees Celsius on the top, degrees Celsius on the bottom, and sure enough, dimensional analysis tells us that joules equals joules. I'm not going to ask you to do that, but just please know that you always have to make sure your units match. That's really important, especially when you go to look up the specific heat on the internet. Please do not look up the specific heat using calories or Kelvin. Make sure that you're looking up the exact units that you need for your equation. One other final note, the change in temperature, so this variable right here, make sure when you calculate it, you are calculating the final temperature minus the initial temperature. All right, so tool number 1 done. Let's take a look at what we do with that information once we get it. So we used our calorimeter, of course, to get that data. And now we end up with a Q value, and I just want to make sure everyone's really aware that a Q value can be either negative or positive. So, looks like I actually have these backwards. Sorry about that. We should have a positive Q value if the water absorbed energy. That means you had a hot object. And then if you have a negative Q value, then that's going to mean that the water lost energy, which kind of makes sense because the water is going to be colder, so the number is smaller. A smaller number minus a bigger number makes a negative. And so therefore our Q value is going to be negative. Please be aware of that. All that is telling you is the direction of the heat flow. Was it flowing into the water or out of the water? But for our intents and purposes, we really only care about the magnitude of this heat change, because remember, our lab is comparing different substances' ability to cool down or heat up water. So don't get too hung up on the negative or positive here, because for comparison's sake, we just want to know the magnitude of the Q value. Okay, final thing, final step. You cannot compare all of your different items or your substances that you put into your coffee cup very fairly if they weigh different amounts. Because you might have one that has, for example, 2,000 joules, and then you may have another one that's maybe 1,500 joules, but it just may so happen that this one you had like 500 grams of it, and this one you only had like 20 grams of it. Well, of course it's not going to have as much energy. There's just not as much of it. So you have to now, for every single one of your substances that you place into your calorimeter, or every little bag of reaction, like whether you used, something to heat your hands or cool your aching muscles, if you use some of those little reactions in a bag, then now you have to actually do the conversion where you divide by the number of grams. So for example, if we take the first one, 2,000 divided by 500, and you guys know the little trick, right, where you can cross out the zeros, makes it a little bit easier. So that's going to be 4. So that's going to be 4 joules per gram. Okay, do you guys see how I did that? And so that way you can actually compare that 4 joules per gram to do the same exact division for the next substance, the 1,500 divided by 20. Once you get that number, you'll be able to compare the two. And so at the end of the day, you'll be able to say which one of your substances either absorbs more energy or releases more energy. And then the ultimate question of the lab is you are looking for a way to make the best DIY, either air conditioning unit or heater. And so you will be able to look at your substances and say, hey, I think substance A works better because it absorbed the most heat energy. So always keep your context in mind too as you're conducting this lab. And hopefully this helps you a little bit with what to do with your data. Thank you.